Hey, what up, guys? This is Nick the Quant. Today I got another post for today's highest mathematical edge pick. Yesterday I gave you guys the San Francisco Giants on the money line. Unfortunately, that missed. They lost 6-3. Was a good game, and then they just had one inning where they just gave up 3 runs, and that came out to be the final score. But we beat the closing line by over 10% on that pick. There was clear mathematical advantage and obviously very large pricing advantage due to large expected value. So the market confirmed that this was the right pick given how largely we beat the closing line by. Just unfortunately didn't go our way. Saying that though, we did go 3-1 on the day, so it is always nice to at least see good accuracy. But because that was our highest edge pick, overall, if you tail all of my picks, it would have been a loss of about 1.2 units. But if you took that pick only, then you would have lost more. And that's why I always say that I always recommend that you go to my X account where I post all my free daily sports betting plays. That way you get more, it just helps smoothen out variance rather than betting on one singular outcome every time. You get access to all my picks and plays. And it's just honestly better for bankroll management. And then saying that, I'm always posting my daily results, and I always post my highest mathematical edge pick first to my Instagram account at Nick the Quant. And then as far as all my picks being posted just right as the model runs. So, I post all of my picks first on my X account at Nick the Quant 44. And then my YouTube here is where I post my analysis video pretty much after all that happens. And I just provide insight into the highest mathematical edge pick. You gotta excuse me. I'm very congested right now, but I'm trying. So saying that, we can get in today's highest edge pick. Today we have the Toronto Blue Jays on the money line. My model has them at a 47.62% probability. I got them on DraftKings right around plus 134. Most books have them ranging from high 120s up to, I saw a few, like I think it was Bet365 and a few others, to the high 130s, even low 140s. So this is a position where if you can, try to obviously get them as the largest underdog possible. So again, saying that, my model has them at a 47.62% probability. So relative to their pricing, we have a large pricing advantage. My model views the Blue Jays as being heavily undervalued and the Yankees as being heavily overvalued. So saying this, my model sees the Yankees as having a negative 17.34% expected value. And then, as we just discussed, the Blue Jays at a plus 15.72% expected value. Using Kelly Criterion to size our risk based on the amount of probabilistic edge we have in this matchup, that comes out to me risking around 1.83% on the Blue Jays, which is 1.83 units, as 1% of my bankroll is 1 unit. So now I'm going to take you guys in the math. We're going to go through all 9 interior models of my ensemble model. They're all calibrated based off of their empirical outcomes, meaning how do the actual initial predictions perform, and then how that initial prediction that my model gets, in this case on the Blue Jays or the Yankees, how it actually performs in real life is what their calibrated probability is. That runs through all 9 of those models, and each model is weighted based on the amount of sample size of those actual empirical outcomes. That's how much they can contribute to that initial ensemble model probability output. Then when that happens, you have that initial ensemble model probability output. Then that gets calibrated at a second layer via the use of empirical Bayes, which takes into account both the model output, but then also the amount of sample size of that model output. The more sample size there is, the more we can now rely on just the actual historical empirical outcomes. Less sample size there is, you put more into account of the model, while as time goes on now, you're slowly shifting more and more over to the empirical outcomes, because that's where reliability comes from. Instead of blindly trusting a model, you can actually see where it correlates in real life. And then I do a third and final layer of calibration based on the market region that the teams align in. So saying that, we can just honestly spin through this. The Yankees were favored in my first model. Their empirical outcome rate is at 56.79%. So model 1 is the Yankees at a 56.79. Model 2, Yankees at a 61.90. Model 3, Yankees at a 62.34. Model 4, Yankees at a 66.67. Model 5, Yankees at a 53.33. So no, honestly, all of those signals, again, those are the real empirical winning rates of those initial predictions the Yankees had in those 5 models. All of them so far strongly into the Yankees' favor. Again, though, you got to take in the sample size amount of those initial predictions, There was only one out of all of those that would be negative EV, still in favor of the Yankees, but not relative to their pricing, and that was Model 5 at that 53% range. Model 6, Yankees at a 51.50, so again, in favor barely of the Yankees, but relative to their price, largely overvalued for the Yankees. Model 7, Yankees 58.59. Model 8, Yankees 46.67. So there's our first contrarian signal on the Yankees right there. And then Model 9, our last model, had the Blue Jays at a 65.85. That last model right there for the Blue Jays has been a very, very well-performing initial prediction for the Blue Jays. So it's initial prediction of 54%, but it's been hitting at a 65.85% clip on the season, and it has very respectable sample size. So only one model, well, technically two models, were contrarian to the Yankees. One was the Yankees' initial prediction being contrarian, which was that previous model, and then this model right here, just being in favor of the Blue Jays, and then it performing very well in empirical outcomes. So relative to the sample size of all those predictions and the empirical data, we can then consult that initial ensemble output, which for the Yankees is a 54.9% probability. So that right there alone is a big pricing discrepancy relative to the Yankees' odds. But we need to see how that initial probability has been performing. And when my ensemble model is outputting 54% probabilities, it's been hitting at a 54% rate, showing pretty high accuracy. It's a so far reliable probability. So second-layer calibration makes the Yankees at 54.54%. So it just honestly pulled it down more towards 54 since they were initially at 54.9. Very negligible, though it went from a 54.9 to a 54. So lastly, now we have to assess what the market region is that the Yankees are in. So the market region that the Yankees are in today at the time of my analysis, right, is they're in a market region that overall, when teams are in this market region up to this point in the season, they only have a 48% win rate. So relative to the whole market, this would be a contrarian signal. Not significantly. We're running 2% below indifference, which would be a 50-50. But so relative to the market, slightly contrarian. But relative to the Yankees' pricing as a pretty large favorite against the Blue Jays, this is significantly contrarian. It's mathematically not into the Yankees' favor by 2%, or technically call it like 8%, because really anywhere between 51 to 55% you can argue is indifferent. It's not clear mathematical edge here. But still, nonetheless, a big disadvantage for the Yankees' pricing. So we take in now into account the Yankees' market region, like I just discussed, that 48% clip, and we use that and we perform third layer calibration to finalize that Yankees probability. And when doing this, the Yankees finalize at a 52.38% probability. So bringing that back to the beginning of the video, likewise, the complement of that probability, meaning the other side of it, would be the Blue Jays at a 47.62. So we can see that if the Yankees are at 52.38, yet their odds are a minus 173, there is a large pricing discrepancy here. According to my model, the Yankees are very overvalued. And that gives a significant amount of expected value for the Blue Jays at that 15.72%. Blue Jays at a 47.62% probability. And going back to my odds, I'm seeing right here, I actually got the Blue Jays at plus 143. That's what I had meant to say. So, yeah, Blue Jays are a very respectable, sizable underdog, yet my model is just simply not showing that, and the market region for the Yankees is surely not showing that. So this is a very high value, high conviction pick. We've got clear pricing advantage here, and mathematically, right now, defining the Yankees as being very overvalued. So lock this pick in. And as always, if you want access to all of my plays, not just a singular one, you can go to my X account at NickTheQuant44. And if you want to be up to date as quickly as possible about the highest mathematical edge pick, if you look at my X account and see my posts, I show the expected value and the risk amounts. So you can kind of already see it right there when I'm showing, okay, like, this one has the highest EV, it has the highest risk. You can get that right there. But if you just want to be sure, I then go right to my Instagram account and I say, okay, here's today's highest mathematical edge pick. Then I come here for the video just to kind of show the transparency of the math. I really enjoy the math behind this stuff. My goal is, whether it's baseball, I'm excited for college football coming up, whatever it is, I want to be the best predictor possible. I love the art of prediction, and I really, call me delusional, don't know, but I really do think that there's possibility when using probability theory and statistics to be exceptionally well at predicting sports. Baseball, I would argue, is probably one of the hardest, but sports like football, basketball, even hockey, whatever it might be, I'm a huge believer in the math because I know what it's capable of, especially when you have a large enough sample size and you're doing it in a long-term period, not just season, okay, and then this season. I'm talking about multiple years of seasons. So still in the infancy right now. This is my first time ever betting on baseball, or should I say predicting baseball in general, but the data accumulation will compound just like if you're investing in the stock market. If you have proprietary models, you're not constantly changing things, and you treat them like you would a stock portfolio, and you're just flooding them with data, just like if you were doing dollar averaging in an index fund, and you're looking for that compounding to take place. This is the same way. Your probabilities become more accurate. Variance shouldn't be so apparent anymore. I mean, it still happens, especially in sports, but it will smoothen. And so this is a great kind of way to ensure mathematical forecasting for a long-term time horizon.